Hello and welcome back. Let's talk about orthogonal and orthonormal bases. Bases. I'm not sure what the plural is there, but multiple bases. So an orthogonal basis is a basis where all the vectors are at a right angle, or orthogonal. And, well, that looks like this. Just like that. So they all have right angles. You could think of them as the x, y, and z axis. That's a great example. Or the IJK basis. Those are orthonormal bases. The only difference between an orthogonal and orthonormal basis is that an orthonormal basis is made of normal vectors, vectors with length 1. So I, j, and k form an orthonormal basis, which is also orthogonal. So let's talk about how can we make a basis orthogonal first, and then we'll talk about how we can make it orthonormal, which is a much easier transformation. So let's look at the vectors from the last video. I believe this was it. Yeah. So let's draw them. V1 goes over 1 and up 2. And V2 just goes back 1. So it's clear that these are not at a right angle. And it's much easier to see in 2D space than 3D. But we can clearly see these vectors are not orthogonal. Now, how can we make these vectors orthogonal? Well, let's just name the basis U1 and U2. And let's say they're orthogonal. Well, we can let U1 equal V1. But now we need to make V2 orthogonal to V1. So what we'll say is that U2 is V2, but then we want to subtract the projection of, there we go, V2 on V1. And basically what we're doing is taking away the part of V2 that is not orthogonal to V1. So what you're going to get here is that U2 is, well, V2 is minus 1, 0. And then we're going to subtract. In the past video, we found the projection of V2 on V1 to be 1 over 5 times the vector 1. So we're just going to add 1 over 5 times that vector. And what we're going to get is negative 4 over 5 and 2 over 5. And so that's our orthogonal basis. Okay, beautiful. These vectors are now orthogonal. How can we make them orthonormal? Well, all we have to do is name our orthonormal basis, N1 and N2. And now what we can do is divide U1 by the magnitude of itself and divide U2 by the magnitude of itself, and they must be normal vectors. So, N1 is U1, which is 1, 2. And then we're going to divide this by the square root of 1 squared plus 2 squared. So that's 1 plus 4, or the square root of 5. Finally, we say that N2 is our U2 minus 4 over 5, 2 over 5, divided by its magnitude. Now, we have an issue here. thing is, the square root with the squares of these numbers is going to be very hard to do. So all I'm going to do is times u2 by 5. And what we're going to get is minus 4 and 2. Now these vectors are still going to be orthogonal, because if I have an orthogonal vector, u2, and I just scale it, it's still going to be orthogonal. Now if we divide that by the actual magnitude of that one, which is negative 4 squared, which is 16, plus 2 squared, which is 4, we're going to get 1 divided by root 20 times minus 4, 2. Now we could also bring out a 2. Sorry. We're just scaling this vector down again. Make sure that we keep the 2 there this time. And this could be thought of as root 4. And so what we'll get is that n2 is 1 divided by root 5 times minus 2, 1. And that is our orthonormal basis. Whew, that was a lot. But it's really not that bad. It's just a lot of work. So thanks for watching. I hope this video found you well and did good at teaching you. I hope to see you in the next one.